what you see here are the students in each one of these teams. And a year later, 3 of these teams are launching with students as the CEOs, students as the presidents, students as the chief technology officers for these companies. And they're going to transform life here on Earth, and they're going to create more opportunity there in Brownsville because they took the technology, they took their education from the university, and they're going to impact the lives of the people that live in their own neighborhoods. And so what happened here in Brownsville can happen everywhere. And for those that, as you heard, there's so much going on there through Guayaquil Space, and Robert can connect you, but there's also activities going on in Puerto Rico. And back in last November, I went to Puerto Rico to visit with Parallel 18. Great organization that every year will do a call out to all of the countries in the Americas to be able to see who's got a technology, who's got an idea that they want to be able to create a company. And they invite them to Puerto Rico, and they work there for a few months to help them launch the company. And this last year, we were going to try to do the same thing in Puerto Rico, reaching out to the whole community to be able to move NASA technology and create companies that would transform life throughout Central and South America. And we almost got there, but of course, COVID shut it down. But I know that that team is still wanting to do it. So I would ask you to keep looking out to what's going on in Parallel 18 to see what's possible, to see if you might be able to one day work with them to move technology to create new industries and new markets in your community. And we've done things with New Mexico, with the community out there to be able to help them grow companies. And up in New York, they were actually, through the New York Space Alliance, they were creating companies down in Brazil with technology that came from NASA. So lots possible. It's up to you and your imagination and your drive to be able to pursue and to make it happen. And so finally, I hope that as you graduate, as you go into your careers, as you look forward to seeing what's possible, that you will remember to follow your imagination. Don't let anyone ever tell you that it's not possible. Don't let anyone ever tell you that you don't have the skills, you don't have the ability to do it. And please remember that the opportunities out there are endless. The future is wide open. And if you are willing and wanting to, please help us make this vision a reality, and maybe even be one of the people that steps foot on Mars and looks at this incredible view. And with that, thank you so much for your time.
Thank you so much, Stephen. Here we are clapping for you from everywhere.
Thank you, Karina.
Incredibly inspiring. And sometimes as children, we hear is listen. Well, don't listen. just go for your dream. If you need to listen to anybody, just listen to Stephen Gonzalez. He said, hey, go for my dream. And it's incredible when you mentioned about art, because we think of STEM and sometimes we forget about STEAM. That's science, technology, engineering, arts, and math. And for us poets who look at the moon and the stars and see beyond, and for artists, we need to realize that that is also an industry that can be widely changed by what we learn and by what we investigate, and also but how we can utilize whatever inventions are available from what the space can bring us. Now, sometimes when we talk to students, or when we talk to children or grandchildren, we say to them, well, make sure that you study something that can be easily transferable. So, for example, if you study law and you live in Ethiopia and you're a lawyer in Ethiopia, basically you're limited to that. Now, if you learn how to cook or how to be a healthcare worker, you widen up your dreams. But if you're able to work in science and math, then there is no limit. There isn't even a limit within the Earth. Space is out there for you. Today is the 24th of November. Tomorrow, November 25th, is the International Day for the Elimination of Violence Against Women. If women can use our education to leave a toxic relationship, that is survival. So don't just think about education as a way to get to your dreams. It's also a survival technique. And thank you so very much, Stephen. We're gonna go on with Leonardo Guzman now, and after Leonardo, we'll welcome the students from ESPOL, and then we'll open some questions, which I'm sure there are many questions out there. Thank you so much, Stephen. Big round of applause for Stephen. Leonardo Guzman was born in Venezuela, and he studied architecture at the Universidad Jorge Tadeo Lozano, say it right? Jorge Tadeo Lozano in Bogota. And he's also one of those people who said, well, I can go beyond. And just as Stephen was saying, that there are places that can be constructed in space. Well, Leonardo Guzman is one of those people who can actually build those places somewhere. You just name it. He's actually, he has a Master's of Science degree in space architecture. So working with CAD, actually, was it your thesis, Leonardo, that you presented it at the International Conference of Environmental Sciences? And that's another thing. Sometimes we see countries with several challenges, political challenges, economical challenges. But then again, science can get you out of there, and Leonardo is living proof of that. So with that, we welcome Leonardo Guzman. Thank you so much, Leonardo.
Hi, hello everybody. Hola a todos que hablan español. And speaking with Robert, we're gonna tape this and put it up on YouTube with Spanish subtitles. Entonces vamos a montar este video con subtítulos en español para los que no escuchen muy bien o entiendan muy bien inglés, para que podamos todos ver lo que vamos a decir, lo que hemos dicho hoy. So yeah, I'm gonna start presenting. 1 second. All right, are you able to see it here? Okay, perfect. All right, so from architecture to space architecture. So how Karina was saying, I studied architecture in Bogota, Colombia. And in a period of around 2 to 3 years, I had this change in my mind that was kind of rapid, and I call that a creative explosion of some sorts, where I was, say, in the middle of Bogota in a very little, relatively little art school studying architecture, and I was going on the bus, and 2 years later, I'm designing space stations and talking to astronauts, which is kind of a shift that not many people do, but it happened to me. Since it happened to me, I want to explain kind of how I got there and my process to it. So this is an image of my master's thesis, which I also expanded on for the International Conference of Environmental Systems. Essentially an optimized space station in low Earth orbit. Low Earth orbit is spelled as LEO, so it's Leo, so there's that ongoing thing that's my name too, but coincidence. Essentially, this space station took the form of the rockets. I don't know if you, in looking at Stephen's SpaceX launch, the fairings are the top part of the rockets that reach orbit. So my proposal is to actually pressurize these fairings and reutilize them as large space stations that could function in low Earth orbit. So going into my history, I was studying civil engineering for 2 semesters in Bogota and Universidad Javeriana, where like a lot of people, a lot of students nowadays, you start a career and you're not really sure what you want to do. And I wasn't sure. So my mind was always ranging from drawing. So I like the arts, I like architecture, but I also like science and engineering. So I was in civil engineering for 2 semesters, and in being there, I decided, hey, I think I want to create. So the civil engineer, he builds for the architect's idea. So I was like, what if I get the first idea and then see how it's built? So from that scope, I transferred to Jorge de Lozano University, a smaller school where my mind started to realize that the full scope of a building or a construction. If you think about it, an architect, he sees the whole of whatever he's creating. And then from that whole, he makes subsystems. So subspaces, you have to understand how the structure of the building works. You have to understand where the plumbing, have an idea of how the electricity is moved around the building, and you look to optimize. So essentially, people talk about how design is, or the arts are purely aesthetic principles. What I say always is that design is actually an optimization tool for different systems. So after Latadeo, I came to the United States, back to Houston, because I used to live here before, and studied a Master's of Science in Space Architecture. But you're saying, wait, there's a jump here. Like, how did you make this transition? So back to when I was on the bus, I started to understand that in order for you to understand, to work in different fields, you have to have the 2 sides of the brain. Usually these are the diagrams that we're all shown, where we have both the right and the left side of the brain. Each one is logic and the other one is creativity. But it turns out that there's this part, this is my favorite part of the brain, which is kind of a weird thing to say, but there's a corpus callosum, which essentially is the center part of the brain that connects the 2 hemispheres. So both of our hemispheres work together. What happens in education and conventional education is that in studying one specific field, we get hyper-focused on one specific type of subject. And that essentially kind of takes apart one side of our brain. So I was thinking, if we have this connecting piece, what if we can optimize both sides of our brain so that they start working together and enhance each other? So you can be a scientist and like Albert Einstein and play the violin. So I know his what he's wearing is not the most nice tuxedo, but it doesn't matter. What I'm trying to say here is that he was one of the smartest minds that we've ever had. He's one of my idols, Albert Einstein is. And during this time, I decided that not only studying architecture, I wanted to learn a lot of things. So I started learning physics on my own, because I understood that when in studying architecture, I wasn't going to get the full scope of things. I was going to get an overview of how a building works, but I also wanted to understand the engineering side of things. So I started to investigate on engineering, physics, even chemistry. I would read some books on, and I was even about to start studying physics when my brother called me one day. He's like, hey, there's this program at the University of Houston that's called Space Architecture. So I looked at it and then I applied and I got in. So a little bit of my work during architecture, essentially you have to design plans and facades and see how buildings are distributed. So it's essentially, architecture is a good place to be because it's a center between both design and more logical aspects of construction. So in architecture, you have to take into consideration sustainable design principles. So For example, how much hours of sunlight each side of a building gets, and how do you distribute that direction for it to receive the most or least sunlight depending on how hot or cold the environment is. So for example, in this project, I decided to work with greenhouse heating. So there was an interior volume. These were student housing. This is a student housing project where I did two layers of walls. One had glass on it, and essentially these patios, they became kind of like a greenhouse. So the hot air would come in, we would get diffracted by the windows and produce heating. And since a lot of us, well, the people who have been to Bogota know that it's kind of cold and it rains a lot, heating up the sides of the rooms was like an important thing. So you would also have to think about the circulation of the wind. So how are you gonna solve for that? So there's all these variables that you have to solve for. And when I got to space architecture, this was very key because in space architecture, you have to deal with different type of variables, but they're essentially variables. So the way of solving a problem for space is analogous to how you solve a problem for architecture. So it's these jumps of one field to another, and what concepts can you take from one and apply to the other, and that generates new types of solutions. So it's a multidisciplinary focus. So they teach us how to perceive objects as a whole. Buildings are essentially volumes, and we have to understand how each part of the building is connected. So what happened, something weird started happening was that in studying these type of isometric views and exploded views where we get all these details, I would be on the bus on my way home, and then I started looking at a bicycle, and then I kind of would, in my mind, kind of exploded, not exploded, well, like separated into different pieces. And I wouldn't have to know much about bicycles, but in doing that, for every type of object, I started to get an understanding of how things would work. And if I was very curious, then I would get home and then I would investigate some more. So that's essentially a trick that I started doing. And I would do that for, let's say, vehicles too. And I was in this mechanism where my mind was starting to race a little bit more. And as I applied to the program, I never left the arts behind. So in understanding how, let's say, buildings worked, I would do them by hand. So with one drawing, I would try to generate a functioning module. So it would be a blank page, and then I would start from zero, and it would be one building. And then after this, I started working in animation. So add time into the equation, and then a drawing could become a whole series of animations. So I started working with different types of drawings, and this was a little bit more creative, but it's still, I think that's a really nice little video. Next. Great. Okay, so this is Sixa. This is Buzz Aldrin. He went to the moon with Neil Armstrong, and he's very related to the program. He would go by, and well, here's a little scope. Can you hear? Oh, wait, one second.
And I want to welcome you to the Space Architecture program at the University of Houston.
Space architecture. It's not about architects doing space. It's about architectures of space.
The Space Architecture program is the only one in the world. It's really a combination of architectural approach to design and design process with engineering technicality.
And we don't do wallpaper. Space architecture is the logic that makes all these things comprehensible.
We look forward to having many more students interested in the opportunity to design integrated systems around people. So you have your engineers, your architectural designers, your human factors people. It's very much like a small company when you bring together these engineers, because we come out with design habitats, not just parts of systems, but a fully designed habitat.
Our students are, in every regard, full professionals.
Houston naturally is where the astronauts are.
we hope to supply them with skilled graduates that have a systems engineering level understanding of the whole architecture, not just the design and the engineering.
What we do is not the kind of linear learning sort of thing. It's the kind of interactive, let's pick a big challenging project to solve, and let's work together and do it and solve it.
And it's all about space exploration and working with habitats for people.
Six at University of Houston. Very strong voice to be heard and to contribute.
Okay. All right, so let me, oops, 1 second. Let me try to put full screen again. Okay. Is it sharing? No, okay. Okay, now it is. Okay, got it. Perfect. Well, here. Okay, so essentially that's an overview of the space architecture program at the University of Houston, which is the only master's in the world. So essentially, being so close to JSC, which is the Johnson Space Center, we get into contact with people from NASA, different aerospace companies like Boeing, and say there's a certain problem that they want a multidisciplinary team of students to solve. So they gave us these number of variables. So I see them as variables. They can be called objective, goals, requirements. So there's different terminologies that define what a project looks for. And between a group of physicists, engineers, architects, industrial designers. So this multidiscipline is what essentially propels projects to move forward quickly. This is what happens in, say, in technology in Silicon Valley. You have to have both design to optimize systems and the actual engineers to produce the actual product. And between both of them, you get both a very technically sound solution as well as a design optimized solution. So the International Space Station is a space where humans has been living for 20 years. And this was after the Apollo program. And this is where all the experiments are done for astronauts today. And this is what has kept the space industry moving. So, and we find that it's very complex piece of hardware. And it's all the greatest minds in the world have worked to maintain it up there functioning. And what astronauts do has to do with all these types of systems that are very complex. So essentially what space architecture looks to do is to grab all these different parts of a mission and simplify them or get the logic right so that the systems engineering is sound and we can start communicating, kind of like how an architect will communicate with the structural engineer or the electronics engineer. We have to do the same, and a space architect would do the same, but with these other types of variables. And when you add design into the equation of STEM, I know Karina was mentioning that, what you get is SpaceX type solutions. So what SpaceX does and has been doing is optimizing hardware, space hardware, leaning it down so that it's very cost effective and very functional at the same time. So that's essentially what the goal is. And taking this type of approach to any industry, I think is very valuable. So there are moon settlements being proposed. This is a project that is to be done by Search Plus, which is a space architecture company, with Icon, a 3D printing company. So then we would look a lot at projects that have to do with 3D printing. So when you go to another planet, you have to utilize in situ resources, because in a rocket, you can only fit a certain amount of weight of things that you can take. It's kind of like if you would go to a trip to Antarctica, you can't take your whole house. So you have to take specific things. And how do you survive on that? So essentially 3D printing is a solution where you can just send robots or a 3D printer and build the actual places where the astronauts will live before they get there. So this would be kind of a solution to help them beforehand. And finally, there's SpaceX that is projecting to go to Mars, along with NASA, ESA, which is a European Space Agency. There's JAXA, which is the Japanese Space Agency. All these, and there's also the Italian Space Agency. All these different factors and players are working together to push humanity farther to another planet. But what happens? So we're projecting all these great solutions, but in the meantime, what is being generated is knowledge. So through science, through all these experiments of, say we're gonna make a 3D printer for the moon. So while we're designing it right now, a lot of technologies are gonna be developed and optimized. So and that's what the space industry does. It actually creates knowledge and it innovates. And if we get enough people involved from any field, then we can have even more innovations. So this is one of the projects that I worked on, which was essentially an artificial gravity Mars vehicle. So when you go to Mars, there's a third of the gravity that we experience here on Earth. So, and in space, while you're on the way there, you're gonna have zero gravity. So your bones, they're not gonna be pulled by anything. So essentially, artificial gravity is a concept that would generate, how the name says, artificial gravity. It's kind of like when you grab a pendulum and you put a weight at the end of a string and you start rotating it, it's gonna create a centrifugal force and it's gonna make you stand up. So this project, as a space architect, what you have to do is define the whole mission trajectory of how you build this machine in space. So we would think of that there would be this long rail, because you need a large radius, almost like 100 meters, and have the central propulsion in the center and rotated using ion thrusters. So this is one of the projects that I worked on, because if astronauts are gonna be in Mars, then they need to complete their task quickly once they've set foot on the ground. But if they're a year and a half in space, which is how long it takes to get to Mars, then their bones are gonna be very deteriorated. So you also have to think about the physiology of astronauts. And all these different factors come into play. So it seems complex, but it's actually, you have to find a way through systems engineering to make it understandable and to be able to transfer information from one person to another. So this is my, I said before, this is my master's thesis. Remember what I was showing about how I would look at bicycles and have this exploded view of systems? I applied the same thing to what I'm doing now. So you have a system as a whole, a project, and you have to think about every little component and how each of those components work together. And that's what essentially this is just imaging, but there's a whole investigation behind it. So for example, how do carbon fiber reinforced polymer sheets work in certain environments, and how do you assemble these things to an interior frame? So this is the scale of, say, the size of a person, and this would be the astronauts in space. And this is a little assembly sequence. So obviously there's extremely more systems and little things that go into it, but as a space architect, you actually just idea how the assembly process would be, and then the nuts and bolts, that's in engineering. So these are projects that take multiple years, but in the meantime, what you develop is research, and there's in academia, what you do is you just develop and you you make publications and scientific papers. These scientific papers, what they do is they work to validate your proposal, and you get to collaborate with other types of engineers or scientists, PhDs, who are all also involved in the space industry. So it's this type of collaboration that can be done between universities, even universities in Latin America, which is one of our important topics today. How can we get students to participate in these type of projects? And I think a key important way to do this would be to think about a very long-term project and see how you can solve it. And out of that research, out of that collaboration, produce research papers or publications for conferences. And if you're lucky enough and you have a sound enough idea, then that paper can be published. And that's when you start getting recognition for your work and moving along in the industry. Oops. Okay. So now we're gonna talk a little bit more about what I'm doing right now. I actually kind of diverted a little from the space industry, but during my time studying there, this was the group project that I did with two classmates. We're essentially using augmented reality. We started to project orbital movement of different planets onto a 3D plane. So essentially with a camera, you can project the position of planets, and it's actually a very educationally instructive method. And yeah, it's very good to see. So there's that. And then once you understand how to work these little technologies, these new programs, this was done with a program called Unity, you can start transferring these technologies to other fields. So think about architecture. So if you have new designs, you can project these onto 3D planes. So we do physical models in architecture. This could be a solution, or instead of the student having to waste all your time and effort in building through little wood things, getting cut, spending nights not sleeping, you can have a 3D model that is actually very close to what the thing in real life looks like. So these are more of my augmented reality works. But I think this is a Harry Potter song. But you can have projects at a scale in your table. And from there on, you can also project it in a one-to-one scale. So for, say, the real estate industry, or people wanting to see how their house looks like before it's built and have an idea, you can either use virtual reality or augmented reality. So with your phone, you're essentially going to be able to see the interior of where you're going to live. So these are, I mean, with these types of programs, you just maybe have to pay a small subscription, and you're going to be able to do these types of solutions. So for space architecture, this is very important because you need to be able to visualize your products, your projects in a, oh, it's very loud, in a one-to-one scale. And in terms of collaboration right now with COVID, having augmented reality as a collaborative tool is a very, it's a topic that I've been looking into. So this is a small cabin, I call it the Sea House. The fun part about this is that it's on your phone, so, and everybody has the capacity to use your phone. So the idea is just to transmit the technology for everybody. And you can also look at urban scales. So if you're an urban developer, how can you project this whole series of buildings? So it's, and have them projected at different scales. very loud. Okay, so. Okay, so this is gonna be, so essentially, oops, okay. So you can see a one-to-one scale. Instead of having to build an actual prototype, before you build a prototype of a space station or a building, you can actually project it and see how it fares with your body proportions. So there's that. And finally, after this, my idea was to make it an actual business. So spin-offs of technologies, how can they be used now? And through an app, an interface, you can actually see the apartments that you want to buy. And you actually click on them and you can project them on your living room. You can see the whole spatial distribution of your architecture projects. So this is one of the types of projects that I'm expanding on right now. Yeah, so let's make it quick. And it's also very fun to look at. I spent like a couple of hours just staring at the possibilities of this technology. So the idea is, as you project these new types of projects for space, in the meantime, you can start working on these technologies and apply them to other industries and even other countries. Kind of what Stephen and Robert were working on with the ventilator. Take that NASA technology and apply it to Latin America. These are the types of solutions that are very positive, and why I think the space industry needs to transition into Latin America and Ecuador, different countries. So stop share. And yeah, so thank you.
Thank you so much, Leonardo Guzman. It's incredibly interesting how you can go from augmented reality, and actually, I think Walt Disney will be jealous. You know, he started animating a mouse and was able to go through the whole Earth. You started animating a bicycle and you're able to go through the whole galaxies. Isn't that wonderful?
Yes.
That's absolutely awesome. And in fact, with that mobile augmented reality app, you can actually make it work for real estate, for architectural design, commercial spaces, hotels, financial activities. It's just incredible. Now, I know we would love to be able to build things like you do with CAD and everything, but we can only go for Lego.
Well, that's a start. Hey, those ladies.
That's a start. That's a start. And in fact, while Leonardo Guzman was talking about the International Space Station, we had a raffle here because it's our birthday. It's our first year anniversary. But the gift is actually for one of you. And Kendi Moreno is actually the winner for the International Space Station Lego. And so Kendi, make sure that you get in touch with Robert Ayon at the Guayaquil Space Society so that you can claim your Lego. It's actually 864 pieces of the International Space Station, and we would love to see it already built. So when you build it, make sure you take a picture and let us know. that would be absolutely wonderful. Leonardo mentioned that it'd be great for different schools and for students to collaborate. And in fact, at the Guayaquil Space Society, there are several educational institutions that have helped. Colegio Javier, the Rice Space Institute, ESPOL, which is the Escuela Politécnica del Litoral in Ecuador, CEMDES, the Alliance Française, and UES, which is la Universidad Espíritu Santo in Ecuador, in Guayaquil. We would like to extend our thanks to the Consulate General of the United States in Guayaquil, Hotel Oro Verde, who welcomed us on November the 6th, 2019, for our first ever meeting here. And that was the founding of the Guayaquil Space Society. Also would like to say thank you to the Mayor's Office of Trade and International Affairs in Houston, Texas, Geoffrey Notkin from the National Space Society. In fact, Guayaquil is also the first space society in South America. FENACAPTUR, that's the National Federation of Tourism in Ecuador. STOES, who help us out with simultaneous translations. Sister Cities of Houston and Universal Suite.
Karina, you're muted.
Don't tell me. If you had only heard what I told. Okay, so did you hear all the thank yous or not? What last part? Okay, I said thank you to Colegio Javier, Rice Space Institute, ESPOL, CEMDES, the Alliance Française, and UES, which is Universidad Espíritu Santo. Now, we also have to make sure we mention, because of all the help we've gotten from the Consulate General of the United States in Guayaquil, Hotel Oro Verde, the Mayor's Office of Trade and International Affairs in Houston, Texas, Geoffrey Notkin from the National Space Society, Holbach Muñetón from FENACAPTUR, that's the National Federation of Tourism Chambers, STOES, that help us out with simultaneous translation, Sister Cities of Houston, and Universal Suite. Now, Leonardo mentioned about student collaboration, and so with that, I would like to welcome ESPOL students, Janice Marquez de la Plata, Marcos Moreira, and Steve Marquez de la Plata, who are here to share some thoughts with us. So there's Steven. Steven, you can unmute your phone, and the same thing with Janice and Marcos.
Hello, everyone. How's everything going? My name is Steven Marquez de la Plata, and I am a student from a very known university here in Ecuador called SPOL, specifically in the degree of mechatronic engineering, and I am also a member of the Guayaquil Space Society. I will tell you a small summary of our project, the project that makes us win the NASA Space Apps Challenge 2020. StudentSat was born as an idea that seeks accelerators that support technological initiative to improve education in times of virtuality and eliminate social differences linked to this resource. It is based on the use of data stored in CubeSats, placed in orbit to meet the demand for access to information of students from rural areas where the internet does not reach maximum coverage. With this, sufficient coverage and access to a database will be granted to places with a little access to this media in the region. With the lower cost of these spatial tools, potential solutions will be given to the problems of the fourth industrial revolution linked to equal access to information. So that was our summary about the project, the StudentSats. I will talk to you about why it's important. It is important to develop ideas of this type, even if they are not implemented, because they open the way and create a precedent for other young people and professionals to have an extra incentive to participate in this kind of projects, because they see that there is international support and they notice that they are not alone. I also think that our idea is good because in this context of a global pandemic, it is extremely necessary to keep the social problems in Latin America and around the world under control, such as the decline in education, in which we achieve an impact if we develop this kind of ideas.
Hello. ¿Sí me ven? ¿Sí me escuchan?
Te escuchamos, Marcos.
Hello. Tengo prendida la cámara, no sé si me ven. Bueno,
Yes.
voy a suponer que me están viendo.
Sí te escuchamos. Puedes hablar.
Okay. Okay. Thanks so much. Hello to everyone. I'm Marcos Moreira, I'm a student from the SPOL in computer science engineering career, and I participate in the NASA Space Apps Challenge in 2020. I was very excited because we can win this contest. No sé si puedo decirlo en español, disculpen. ¿Aló? ¿Sí me escuchan?
Lo puedes decir en español y de ahí te metes, te registras al CEN para aprender inglés, ¿te parece?
Sí. Estoy muy nervioso, la verdad. Es la primera vez que hablo aquí en un webinar tan importante como este. Y en serio que no tengo tantas palabras para describir toda la emoción que pude experimentar ahorita y en el concurso. Porque en serio es la primera vez que puedo terminar un concurso de tal magnitud y ganar un concurso de tal magnitud representando a una institución de gran magnitud. Y es por eso tanto mi nerviosismo ahorita, que es sencillamente impresionante el esfuerzo que nos conllevó a mí, a Yanis y a Steven para poder terminar e incluso poder ganar. O sea, claro que mi experiencia pasada en el concurso en 2018, donde conocí a Robert, pues me ayudó bastante y desde que he trabajado ciertas cositas con Robert, pues me ha ayudado, o sea, mucho, no solo en este concurso, sino próximamente, muy posiblemente en mi carrera, en mi vida profesional. Y bueno, quiero pues agradecer a los chicos que me han acompañado y que se han esforzado bastante a pesar de todo lo que pasó. Pudimos terminar y afortunadamente ganar. Aunque claro, curiosamente en nuestro concurso nosotros enfocamos el tema de como dijo Steven, sobre el tema de la baja internet, internet de mala calidad aquí en Latinoamérica. Y eso es algo muy a tener en cuenta, porque ahora, entre otras tecnologías, internet es como el agua de la economía. Y si no tenemos una buena internet, seremos poco o nada competitivos con la nueva normalidad. No por el COVID, sino por la nueva revolución de la industrial 4.0. Así que me siento muy agradecido con el Guayaquil Space Society, con Robert también y con todos mis compañeros. Muchas gracias.
Muchísimas gracias, Marcos. Thank you so very much. Y ahora tenemos now we have Janice and Marcos de la Plata, and she's going to be sharing with us.
Well, in my experience, I believe that the true challenge of the group was to believe in itself, to propose a solution to a current problem on the planet. Sometimes we believe that we don't have no capacity or talent to achieve something, and that is why many ideas are not made now. For this reason, I invite all adolescents who are interested in the subject to take a step and show their solution ideas to the world. Throughout the process, we were also accompanied by mentors from the Guayaquil NASA Space Challenge. So trust and compete in the next challenge, I recommend. Thank you.
That is absolutely wonderful. During our year, we've had several great guests. We had Ellen Baker, who was actually here in Guayaquil, and she was actually at the Hotel Oro Verde. In fact, we are here at Hotel Oro Verde right now. Centro Ecuatoriano Norteamericano had Jeannie and Bradley share with us. Miguel Ayala with Exodus, Oscar Garcia with InFlight Global, Benjamin Rosales, Fernando Mancero, Riley Mike from Sugar House Aerospace, Mateo Alvarez from Axiom Space, Stefan Recchi from Gen Space, Molly Mulligan from Space Commerce Matters, Kali Yakala from Space Nation, Robert Firebach from Zero G Launch, and many more to come. The internet is actually being able to keep us together and be able right now to welcome several of you from some other places that are not in Guayaquil. So we're very thankful to that. We will have a time for a few questions, but I would like to welcome Francisco Sweat the screen. In fact, again, going with dates, 24th of November is today. In 2 days, it's gonna be Thanksgiving in the US. And Francisco Sweat, who was a former Secretary of Finance of Ecuador, he has a master's degree in public affairs with Princeton, a Bachelor of Arts from Wesleyan. Actually, his relatives can be traced down all the way to the Pilgrims and the Mayflower. And so we welcome Francisco here with us. He's a column writer with Diario Expreso in Ecuador, with El Montonero in Peru, with Latin American Advisor. He's also a member of the editorial board of Diario Expreso, and he's the dean of the School of Economics and Business with Universidad Espíritu Santo. Thank you so much, Francisco, for being with us. And he is a founding member of the Guayaquil Space Society.
Thank you, Karina. I hope I'm in the middle of the screen here. Okay. Indeed, this year has gone very fast. I remember last year being together at the Oro Verde site for the launching of the Space Society, and how good we felt about the incoming activity of something that otherwise is considered to be a dream, something unusual. And certainly for a country like Ecuador, it is a brand new experience to think of the stars, the planets, the galaxies, the constellations of the universe, to go back to Einstein, and then quantum mechanics and everything that goes around in the science of the universe, to think about the future of this planet, and not talking about the next 5 years. I'm talking in geological times, what it means as, let's say, this planet comes to an end at some point. This is the domain of the space, and it is in the interest of the Space Society. I have been very well impressed by all the different presentations that we've seen today. Each one of them has added to our current knowledge of the science, of the experience, of the nature of the activity that goes on, of the exploration of the cosmos. And we can only think of the kinds of new findings, new experiences, new opportunities that come from being knowledgeable about the space. In Guayaquil, we have to be thankful for Robert's activity. He has been a pioneer, and I mean a pioneer. He has been an initiator. He has the tools of the creator to put together an idea in his mind because he loves the subject, and then to formulate what he wants to do and to pursue that dream. Dreams, ideas, which are always lodged initially in the mind, eventually become part of reality and they materialize. And I salute Robert in this first year of the Guayaquil Space Society as it has been put together. And I think that it is only good that we mention that, because he was the one who brought me into this matter, not because I hadn't heard of this. I did have a chance to watch the landing on the moon. So I mean that's how old I am now. But the fact is that I have followed the Mercury and the Apollo programs, and then all the rest, the shuttle, and now SpaceX, and all the new private initiatives. But he was instrumental in saying, let's do something here in Ecuador, in Guayaquil. Let's be the pioneers. We have the talent, and we have a competitive advantage, which is given us by geography. Just think of what this world would look like in 20 years, 25 years, another generation, about air transport, how distances will be shortened, how the fact that we are located where we are means that we will have a competitive advantage, natural, God-given, geographical competitive advantage. And what it means for us in just being there and being activists and being a part of the group of highly intelligent people who are thinking these things through and putting together our own private and local talent. Our young students, when I see the young folks from ESPOL, from the Polytechnic School, I can only be proud of them as a Guayaquileño, as an Ecuadorian citizen, and as someone who shares with them the passion for something that is new, something that is different. And remember, it is a matter of not just one generation. The post will pass on. You will get it, and you will be excited, and you will contribute to this trove of knowledge that means space. What we hear today was science fiction back 10 or even say 25 or 30 years ago. But now it's reality. Just think of what you will have in your hands to look at and to do when you look like me. So anyway, be good. Happy birthday to the Guayaquil Space Society. My warmest regard for Robert. Karina, as always, you are way special and manage masterfully a show like this. Thanks a lot for all your attention. Thank you kindly.
Thank you so much, Francisco. And in fact, whenever we can, we are going to be able to go back to meeting all of you live, hopefully here at Hotel Oro Verde. In the meantime, I just want to make you guys jealous. Hotel Oro Verde made us a cake with the galaxies. Isn't that absolutely, absolutely beautiful? So a big round of applause for Hotel Oro Verde. Now, Stephen Gonzalez, Stephanie Brooks, she worked with you at GHP, and she says, hello, she wanted to congratulate you on this. And we do have some questions. Jaime was saying in 1969, Apollo 11 took 4 days, 6 hours to reach to the moon. How long does it take to reach the moon? And he wrote 2020, but I'm going to change that to 2021 because in 2020 we can't go anywhere pretty much. So Stephen, what would be the answer to that question?
The short answer is about the same time. We have technologies that are being looked at for Mars. There is a wonderful scientist here by the name of Franklin Chang Diaz, who has a company also down in Costa Rica. He's coming up with some propulsion technologies that would decrease the time to get to Mars. But right now, all the plans for the moon are using the same type of propulsion technology that we used the first time. So it's about the same amount of time as when we went back in the 60s.
And I have something to add to that. Also, when you think about orbital mechanics, which is the whole physics behind the movement of bodies in space, a lot of the physics stays the same, which are Kepler mechanics. What changes is, would be how Stephen says, the propulsion systems, but up to now, we've been using almost the same type of fuel. So I guess the difference would be about a day if we think about the advancements of technologies, but that's not that much. So, yeah, essentially the same.
Thank you so much, Stephen and Leonardo. Now, Jaime also has another question, and I wish I could tell you his last name, but he only says Jaime there. But he says, can the International Space Station travel slower than 27,600 kilometers per hour without falling significantly down to Earth? Stephen, your turn.
So the question, so every time it decreases speed, it will lower its orbit. So the lower it gets, the more drag it has, the more energy it would take to go back up. How far it can go down, that's a great question. I do not know how far it can go down, but I know that they tried to, there's a safe range that Mission Control is always looking at to make sure that the space station does not go below that orbit, and that would mean below that speed, because then it would potentially put the crew at risk. So yes, it can, but not very much before it starts getting too low of an orbit, and it could drag it back into the Earth.
Thank you so much, Stephen. Now, Stephen, you mentioned that we can have these human-powered ventilators. Now, can we use research in space, research in zero gravity to study, for example, the behavior of viruses and bacteria?
Absolutely. There was one company during the shuttle time frame that was looking at the salmonella virus, and they put it up into space, and they found that in space, it became much more aggressive. And so because of the way it behaved in space, they were able to come up with a vaccine that they would not have discovered here on Earth. And so I know last I knew that they were going through the process of getting approval for that vaccine to be able to take care of salmonella. So yes, in space, because of the microgravity environment there, it does allow things to behave differently. But then again, every day, even the astronauts, the way their body behaves gives them new insights into things they may be able to do on Earth. In the astronaut's body, a lot of times, the way their blood behaves mimics leukemia. And so if they can understand why is it that when the astronauts come back to Earth, they don't have leukemia, what is it that the body does to respond by itself, then they may be able to find cures for leukemia. There's also other technologies that we're looking at, bone loss. If they understand how to reduce the bone loss in the astronauts, they can help the elderly with bone loss in their bodies. So yes, absolutely.
Mhm. That's awesome. Now, Stephen, when we were told Stephen Gonzalez was gonna show up, and he had worked for NASA for 32 years, I particularly imagined somebody who looked like I don't know, maybe 90. Did you go to space and were your cells changed by space, or do you purposely dye your hair white?
That's too sweet. No, did not try to test out the idea of the faster you go, the younger you get, but that would be fun. No, this is all natural. Thank you, Karina.
Now, Andres has another question, and it's for you, Stephen. If you were to go back to college right before graduation, what would you do, or what steps would you take, knowing what you know today, to get your feet into NASA's door?
Before I graduate, that's a great question. So number one, now I would have done an internship with NASA. So I would have spent more time at school, because I tried to rush through school and not do any internships. I didn't do any co-ops. So I would have taken more time to be able to make sure, because now NASA only hires through those programs, through those college programs where you get to work a summer or you get to work a semester in NASA. The second part is that now with everything's going on, I would have looked for opportunities in other space industries. I had one student that I was mentoring who wanted to get to NASA, but I told him with what he wanted to do, he was better going to either SpaceX or Blue Origin, Jeff Bezos' company, or Virgin Galactic, the company that is owned by Richard Branson, and there's so many other companies. So if I were a student today, I would look at some of these other companies, some of these fast, smaller companies, because if there is an opportunity to do more in some of these companies, then you could right away at NASA. So I would, if I were a student all over again, I would really expand my scope beyond NASA.
Mm-hmm. That's great. In fact, I heard somebody say once, if you really, I mean, you have a choice. You can either kill yourself studying for 4 years and breeze through the rest of your life, or breeze through college, not doing anything, and then kill yourself trying to survive for the rest of your life. And it's actually pretty simple once you put it like that. Yes.
Since you talked about, there's also the whole idea of entrepreneurship, and a lot of people don't think about how you can start up a company and not have to breeze through college. You know, just create a company. I don't need to go to college. From what I shared today, that would have been a third option I would have looked at when I was in college. I would have tried to figure out how I could be a part of a startup while I was in college. If there was an opportunity to be able to, while I'm in college, while I have the safety of being able to work on my degree, have a place to stay, live, not have to worry about living off of noodles for the time, then I would work on a startup while also trying to get my degree.
That's awesome. Thank you so much, Stephen. Leonardo, somebody with Paul Del Valle asks, what app do you use in order to create the models?
Yeah, well, I do the modeling in Cinema 4D, which is a 3D modeling and animation software. It's kind of like Blender. I don't know if they've heard of it, but essentially it has a really good user interface that you can volumetrically shape things without many polygons, which in technical terms, that's how you make 3D models less heavy. So it optimizes the functionality. But the augmented reality in itself, I do it in a program called Unity with diverse plugins. So Unity is used, I think, a lot in the aerospace industry. And also right now they're using for virtual reality. Yeah, so it's Unity. Yeah, that's essentially one of the main ones. And it depends on the type of plugins that you want. So for example, Google has an AR plugin that's called Google AR, and Apple is also getting into this technology because Apple is trying to advance on their augmented reality functions for iPhones and also projecting to have glasses. So kind of like, so you kind of start projecting where industries are going. So in terms of augmented reality, Apple is looking to take out glasses. I don't know, they're saying maybe next year or the year after that, but it's gonna be soon. And it's gonna function essentially like an Apple Watch. I was having this conversation with a friend because for glasses, so you can think about projecting a 3D model onto the glass, and then it's kind of like sci-fi where you're gonna see people's faces or seeing a building and it's gonna tell you some lines of things. But what happens there is that you have to take into account the movement of the pupil because the human eye, so the software, essentially they have to look at your pupil and take the movement, and that's how you'll get a good functioning 3D model. So it is sci-fi, but we're very close to being there. There are already the HoloLens, which is augmented reality glasses, and there's also virtual reality VR headsets that are being used a lot. They're called Oculus.
Wow, that's incredible. Well, we'll have one last question for you, Leonardo, and one last question for Steven. Leonardo, what is UI or UX designer?
Yeah, so UI UX is user interface and user experience. UX is user experience. It's essentially how the design has to do with human systems interactions. So how is a certain space or a certain object, a product developed for that the human function is very, very straightforward. So as a designer of digital software, you have to think about how the user experience is going to be. So that's like when you look at apps, how are they user friendly? And yeah, and that has to do also with the user interface.
Great, thank you so much. Now, a question to Steven. This is from Domenica Freire Guevara. In this 20th century, we are going through a crisis in cosmology in which astronomers worked with NASA's Hubble Space Telescope in combination with W.M. Keck Observatory's adaptive optics system to observe 3 gravitationally lensed systems. Astrophysicists had several highly precise methods for determining the Hubble constant, and these methods keep returning different results for an unknown reason, and scientists think it could be some unknown property of dark energy. Has there been any recent discovery about the matter? You thought it would be a very easy question. Well, try to read that.
That's an amazing question. Unfortunately, I'm not the right person to answer that. So there's a lot of incredible research being done in dark matter and dark energy, but I don't know what the latest is on that. So I'm sorry, Karina.
Okay, well, since you didn't answer that one, Steven, then I'm gonna ask you what Daniela Jimenez is asking. How is computer science engineering related to space jobs? She's interested because she's a computer science major and she's passionate about it.
Oh, it's all over the place. So when I studied in computer engineering, which focuses more than just programming, it focuses on the hardware as well as the programming. As Leonardo showed, on the SpaceX vehicle, it's all computer driven. The displays are computer driven. The space station, everything on that will take us to the moon and to be able to live on the moon is going to be computer driven. And being able to develop the technology to create the plans, to create the 3D drawings are all, you need the computer capability to create those software packages, to do the analysis. Part of my degree was looking at the networks. So computer engineering also looks at the networks, what makes communication possible. Right now, they're planning to put a communication, almost a cell phone capability around the moon, being able to understand how to connect systems and all of the data and all of the sensors together through that network is all part of computer engineering, computer science. So for that degree, you'll find places all over in space that require that expertise.
Great. Well, thank you so much, Stephen. Thank you, Leonardo, for answering the questions. I would like to thank also CEN, the Centro Ecuatoriano Norteamericano. Consuelo Hidalgo has been wonderful coordinating this. Catherine Carrillo is somewhere around there. Hi, Catherine. And Kurt, je parle français. And I would love to pronounce your last name. I think it's something like Thuret, maybe. But in any case, thank you, Kurt, for helping us with the technology. And thank you, Ingrid Rodriguez and Leonardo. I'm going to try this one. Arrigorriaga. He's the manager for Oro Verde Hotel Guayaquil. They've done a wonderful job. It is my turn now to say thank you to all of you. And thank you for being with us. Thank you for being a part of the Guayaquil Space Society. It's our first year, and first that will actually take us through, how is it? Through infinity and beyond? Is that copyrighted? I hope not. Through infinity and beyond. With that, I'd like to thank Stephen Gonzalez for being here, Leonardo Guzman, Rick Matten, Francisco Sweat, and of course our own Robert Ayon, who is the mastermind behind this. Thank you so much. Please join the Guayaquil Space Society, even if you're not in Guayaquil. See, that's the beauty about this thing. You don't have to pay anything. If you want to become part of the board of directors of the Guayaquil Society, then you do have to be a member of the National Space Society. But we are very happy to be celebrating our first year. We are babies with a lot of knowledge. Thank you so much and have a wonderful, wonderful night. Take care.
Thank you. Bye-bye.
Thank you.